Hello, scholars. I hope all is well with you. This is Mr. Lowe. I am delivering this lesson because this will be your asynchronous lesson for the upcoming week that we are having the PSAT and the SAT here at HF. So this particular lesson will go through some computational work that you're going to need to know how to do when we start with law of cosines, law of sines, and finding the area of a triangle. So both of these lessons are for the CP and the honors classes. So for the CP class, the lesson that you are preparing to learn corresponds with pages 13 and 15 of your notes packet. If you are in honors, then this lesson corresponds to pages 17 and 19 in your notes packet. So with that being said, you are strongly advised to watch this YouTube video in its entirety and to fill in the notes page. Then you will use this notes page to work on the assignment that goes with it. Please keep in mind, this will not be retaught in class. So you need to make sure that even though this is an asynchronous lesson, that you take notes, you rewind or fast forward as much as you need to so that you can get the instruction that you need. With that being said, we've already done a lot of trig computational work. You are doing right triangle trig. Now we're going to raise those stakes a little bit as we prepare for law of sines, law of cosines, and area of a triangle. Most of the computational work that you will see here involves either order of operations, the concepts from solving equations, and just using a little bit of common sense. So if you can do those things, then you should be in good shape. Main thing to keep in mind, your calculator must be in degree mode. So again, if you have the small blue scientific calculator, you will have no problem. If you have the graphing calculator, then remember for a graphing calculator, you go to where it says mode. Look for where it says radian degree and just make sure that degree is highlighted. As long as degree is highlighted, then you will be good to go and you shouldn't encounter any problems with what we're about to do. So let's start with some computational examples associated with finding the area of a triangle. So the examples that we're doing 1, 2, 3, and 4 go along with finding the area of a triangle when we come to that section later on in this unit. So examples 1 and 2, you're solving for A. So A equals 1/2 times 14 times 8 times the sine of 59. So take 1/2 times 14 times 8 and multiply that out first. So 1/2 times 14 is 7. 7 times 8 is 56. And then 56 sine of 59. Go to your calculator and take care of that. 56 sine 59 gives you 48.001. So 48.001. So again, I'm going to 3 decimal places because that's how it was taught in previous sections. Obviously, you read the problem so that you can get how many decimal places you should be rounding your answer to. Example 2 is pretty much the same way. 1/2 times 17 times 5 times the sine of 122. Now, if you have a scientific or a graphing calculator, you can put this all in the calculator. You can put it all in the calculator exactly as it's given. You just have to make sure that you do it correctly. So in the case of if you're going to put it in there all at once, which again, as long as you type it in there correctly, you shouldn't have any issues. So if we type it in, you have 1/2. So 1/2 I put in parentheses like that, times 17 times 5 times sine of 122. And you have 36.042. 36.042 as your A value. So you can put it all into the calculator and it will spit you out the answer. If you don't want to put it all into the calculator, then you can do it exactly the way that we did it in example number 1. 1/2 times 17 gives you 8.5. 8.5 times 5, 42.5, and then 42.5 times sine of 122 gets you to your particular answer. So example 2 is simply to show you that you can put everything into the calculator and get your answer that way as well. So moving on to examples 3 and 4. So 3 and 4, again, you're evaluating an expression. So evaluate the formula S equals A plus B plus C divided by 2 when A equals 11, B equals 16, and C equals 7. So if we're evaluating, then take numbers, plug them in. So S equals 11 plus 16 plus 7 divided by 2. So then you're just doing the computation. 11 plus 16 is 27. 27 plus 7 is 34. 34 plus 2 divided by 2, 17. So S equals 17. That's that. So basic evaluating and solving out the expression. Now, this S formula is known as the semi-perimeter. Now, we'll get into more of that when we actually study this particular section on area, but you need this formula to solve example 4. So example 4, evaluate A equals the square root of S times S minus A times S minus B times S minus C when A equals 12, B equals 9, C equals 4. So notice that S is in the problem, which uses the formula from example 3. A, B, and C are obviously where A, B, and C goes. So first off, since you need to know what S is equal to, you need to solve for S first. So solve for S first. So 12 plus 9 plus 4 divided by 2. 12 plus 9 plus 4 is 25. 25 divided by 2, 12.5. Now that we have what S is equal to, we're going to plug it into the big formula. So now we plug it into the formula. So S is 12.5. And you have 12.5 minus 12. 12.5 minus 9. And 12.5 minus 4. Sorry, it's a little squished up on that part. So now it becomes order of operations. So order of operations means you start inside the parentheses. So solve out the values in the parentheses. So that's 12.5 times 0.5. 12.5 minus 9 is 3.5. 12.5 minus 4, 8.5. Parentheses, there are no exponents, so now we multiply the values out. Everything underneath the square root, you can literally put it into a calculator and multiply it out. So that's 12.5 times 0.5 times 3.5 times 8.5. 185.9375. 185.9375. And then just take the square root of that answer. So square root of your answer, 13.63589. So 13.636. 13.636. So once again, keep in mind, I'm rounding everything to 3 decimal places. If the directions ask you for 2 decimal places or 1 decimal place, then you follow what the directions ask you for. Other than that, you should be in good shape. So for the first half of what we're working with, first examples 1, 2, 3, and 4 are all associated with area. If we're finding the area of a triangle, which we will do a full out lesson on finding the area of a triangle. However, if you know how to do these computations, then you'll be in excellent shape. So the second half of this lesson involves the computation that you need for law of sines, law of cosines. Law of sines and law of cosines are 2 other ways to find sides in a triangle. You use these when you do not have a right triangle. So again, there will be formal lessons with this, but we're going to go ahead and do the computational work now. All right, so with examples 5 and 6, both of these examples are examples aligning to the law of sines. So the law of sines is one of the 2 methods. So for example 5 is what you would be using to find a side. And example 6 is what you would be using to find an angle. So for example 5, solve for A. If you look at the problem, it's pretty much set up as 2 fractions. So the clue for you there is to cross multiply. So clue here is to cross multiply. So sine 48 times 15. So 15 times the sine of 48 equals A times the sine of 25. So cross multiply. Now you divide. So you want the variable by itself. So to get A by itself, divide both sides by the sine of 25. So the sines of 25 cancel out. So then you, in this case, use the calculator. So 15 sine 48 over 25. So we let the calculator do its work. 15 sine of 48 divided by 25. 15, I'm sorry. Yeah, by the sine of 25. So 15 sine 48 divided by the sine of 25, 26.376. There's your answer. 26.376. Sorry about that. So cross multiply, divide to get the variable by itself, and then use your calculator to get your answer. Again, pretty simple stuff. Pretty simple and pretty straightforward. Now, example 6, now we're finding an angle. So it adds one additional step to it, but nothing too difficult. So once again, we have two fractions. So first step is to cross multiply. So if we cross multiply, sine 115 times 11, 11 sine 115 equals 20 times sine of b. So your next step is still to divide. So you want sine of b by itself, so we get rid of the 20. So we go ahead and get rid of the 20. So at this point, if we go ahead and we use the calculator, you get sine 11 times sine 115. Make sure you close the parentheses after that 115. The 20 was not inside of the parentheses, so don't do it. Divide it by 20. You get 0.498. So 0.498 equals sine of b. So the last step there, sine of b. So since you are looking for an angle, when you're looking for an angle, that's when you use sine inverse in your calculator. So now you have to use sine inverse. Go sine inverse of 0.498. So go to your calculator. Second, sine 0.498. Close the parentheses. Hit enter. You get 29.8. Remember, when you're looking for angles, you round to the nearest whole number. So if you round to the nearest whole number, 29.8 gives you 30 degrees. So angle B in this case ends up being 30 degrees. So in this case, so you're gonna end up using the calculator 2 times. You're gonna use the calculator once when you divide, and then you'll use it again when you do sine inverse. So you have 2 steps in which you will use the calculator. So there's 2 steps there in which you'll use the calculator. So again, examples 5 and 6, those are for the law of sines, which you'll get to later on in this unit. But this is simply the computation that you need to do the calculator practice ahead of your asynchronous lesson. So 5 and 6 are for law of sines. 7 and 8 are for law of cosines. So our last 2 examples deal with the law of cosines. So example 7 is if you were solving for a side. Example 8 is if you were solving for an angle. So you're solving for b. B squared equals 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of 34. So if you're using your calculator, first thing you can do is literally take everything on the right-hand side and put it in the calculator. Take everything on the right-hand side and put it in the calculator. So you've got b squared equal to everything on the left-hand side, right-hand side goes in the calculator. So that's 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34 degrees. So the only thing you really have to do is to make sure you typed it in correctly. You get 61.656. So b squared equals 61.656. All right. Not too bad. Last step, take the square root. Take the square root of both sides. So go back to your calculator. Second square root, 61.656. And you get 7.852. You end up with 7.852. So again, you're getting a lot of just calculator work. This is a lot of calculator work, calculator practice. Put everything on the right-hand side in the calculator, get your answer. Once you get your answer, take the square root, you're finished. So last example. Last example is for finding an angle. So cosine of angle C equals 4 squared plus 9 squared minus 7 squared divided by 2 times 4 times 9. So my advice is always work out the top first and work out the bottom second. Do the top and the bottom separately. So if you work out the top, 4 squared plus 9 squared minus 7 squared. So put the top, I'm going to use the correct terminology here, put the numerator in the calculator. So 4 squared plus 9 squared minus 7 squared, get 48. Then put the denominator in the calculator. 2 times 4 times 9. Some of you might also be able to do that in your head. That's 72. So cosine of C equals 48 over 72. You might be tempted to, oh, well, I can reduce that. It's not necessary because you're getting ready to use it. You're getting ready to still do another step with it, so it's not required for you to reduce it. So your last step is to use cosine inverse, which is going to require the calculator. Why cosine inverse? Again, you're looking for an angle. Angles require you to use the inverse. So cosine inverse of 48 over 72 will give you what your angle is. So second cosine, that will call up the inverse. 48 divided by 72. Hit enter. You get 48.189. So angles always go to the nearest whole number. So that's 48 degrees. So that ends up being 48 degrees. So remember, if you're looking for a side, that's 3 decimal places. If you're looking for an angle, you go to the nearest whole number. So not hard concepts to put together. You just have to pay attention to what you're doing. With that being said, this completes your asynchronous lesson for basic calculator practice involving trig. These are things that you will be learning and using more in depth when we do law of sines, law of cosines, and the area of a triangle, which will come after we finish up SAT, PSAT, and the Easter holiday. So it is your responsibility to watch the YouTube video. Feel free to watch this video as many times as you feel as you need to fill out your notes page. Fill out the notes page. That way you have it. And then, of course, complete the assignment. Again, this lesson will not be retaught in class, so you need to watch the video. Of course, I'll take questions, but you need to watch the video. And then, other than that, wish you good luck with learning. You'll do a great job. Take care and have a good one.